So first, let's simplify 7 times square root of 90. If you type that in your calculator, 7 times square root of 90, you get 66.40783086. And that is an approximate answer. And for some teachers and some things that you're doing, sometimes that's okay. But a lot of times in math, we don't like answers with the decimal. We don't like irrational answers, because if you're like sending a rocket out into space and you're off by just a hair, you're going to miss the planet. You're going to miss whatever. So we need to know how to take this 90 and simplify what's in the radical. And so the work is right here. If you think about 90, and this is called a factor tree. So you think about 90, I usually start with the number 2. Okay, so I think, okay, 2 times what is 90? That's 45. 2 is what we call prime, so we could stop. I then try to take 45 divided by 2. That's impossible without getting a decimal, because 45 is odd, 2 is even. So I can't divide it by 2, so then I try 3. So what's 45 divided by 3 is 15. So this would be 3 times 15. And then if it wasn't divisible by 2 before, it's not going to be divisible by 2 now. So now I try dividing that by 3 again. That's 3 and 5. So we just found that 90 is equal to 2 times 3 times 3 times 5, which is why they wrote 2 times 3 times 3 times 5. Now, from here, there's 2 ways to think about it. The square root of, because this is 9, the square root of 9 is 3, so a 3 comes out. Or for every pair you circle, one of them comes out. So because I circled 2 3s, 1 3 comes out. And then there was already a 7 there. 7 times 3 is 21. The 5 and the 2 didn't have a pair, so you keep them inside. This is called the radical. What's inside is the radicand. 5 times 2 is 10. Now we could check our answer real fast by just simply typing in 21 square root of 10. And they should be the same decimal. And they are. And if you think about 10, the only thing that goes into 10 is 5 times 2. There's no way to reduce 10 any further. So this is called simplifying radicals. So we're going to do another example. Square root of 18. So I'm going to start with 18. I usually start with 2. That'd be 2 times 9. 9 is 3 times 3. So I just found that the square root of 18 is the same thing as 2 times 3 times 3. Three times 3 is 9, times 2 is 18. I have 2, 3, 3. This is what we call an index of 2, a square root. When you get to higher level math, we'll put a 3 there, we'll put a 4 there, we'll put a 5 there. Don't worry, I'm not going to do that to you yet. So we're looking for pairs. I have a pair of 3s. So 1 3 comes out. The 2 did not have a pair, so it stays inside. A quick way to check my work is I could type in square root of 18, and I could type in 3 square root of 2, and just double check. You can see that those are the same decimal, so I know I'm fine. What I want you to do real fast is I just want you to try number 2, and if you're at home, you can hit pause and try it, and then see the answer. Alright, so let's think of 28, and I'll use different colors to separate it. So if I take 28, 28 is 2 times 14, 14 is 2 times 7. So I just found that 28 is the same thing as 2 times 7. So I'm looking for pairs. I have one pair of 2's. So 1, 2 comes out. The 7 stays inside. The 7 is the radicand. If circling confuses you, 2 times 2 is 4. The square root of 4 is 2. Same thing. For every pair you bring out, you can bring out as many pairs as you can. Whatever you bring out, you multiply together. Okay? Number 3. And number 3, if I think about 27, 2 does not go into 27, but 3 does. That's 3 times 9. And then 9 is 3 times 3. So I just found 27 is 3 times 3 times 3. From there I look for pairs. I have one pair of 3. It comes out. But there was already a 3 out there. And then a 3 stays inside. So that 3 comes out. There was already a 3 out there. You multiply those. 3 times 3 is 9. You get 9 square root of 3. Number 4. We take 108. One oh eight's even. That's 2 times 54. 54 is even. That's 2 times 27. 27 is not even, so I'll try 3. 27 is 3 times 9. And then 9 is 3 times 3. So I just found that that's equal to -5 square root of 2 times 2 times 3 times 3 times 3. I look for pairs. I have a pair of 2's that come out. I have a pair of 3's that come out. And then the -5 stays outside. And then the 3 had no pair, stays inside. Then you can multiply these 3 numbers. 2 times 3 is 6, times -5 is -30. So you get -30 square root of 3. I'm going to double check my answer real fast. -5 times square root of 108 and -30 times square root of 3. Notice -5 square root of 108, -30 square root of 3, they're the same decimal. Just a different form. It's a simpler form. That's why we call it simplifying. Okay, number 5. Number 5 means 6 squared. That means 6 times 6. So I'm going to write that as 6 times 6. But 6 times 6, we have a pair. So the 6 comes out to just make 6. And because nothing is left, you have no more radical. In other words, the square root of 36 is 6. So if you bring everything out, the radical goes away. Here, 3 to the 5th. That means you write down 3 5 times. We look for pairs. We have one pair of 3's. Another pair of 3's. This 3 stays inside. It's the radicand. 3 times 3 is 9. I'm not going to make you mess with variables for now. You could do those in Algebra 2. Also multiply radicals. Now the rule is they have to be the same index. So this is a 2 square root. This is a 2 square root. And all you do is multiply what's on the outside together. So 3 times -4 is -12. And you multiply what's on the inside together, called the radicand. 7 times 3, 21. 21 is just 7 times 3. There's no pair, so this is the multiplication. Okay. It's kind of important to simplify first if you can. Like square root of 36 is just 6. So this is really -6 squared. And -6 times -6 is 36. Square root of 9, that's 3. Then you square your 3. Order of operations say that please excuse my dear Aunt Sally, you're supposed to do exponents before you multiply. So that'd be 3 squared 9, make it -9. Here, you have nothing outside the radical. You do it's 1 times 1, which is 1. You don't need to put 1. And then you have 14 times 7. And I would just write that as 14 times 7. 7 is good. 7 is prime. But 14 can be broken down. 2 doesn't go into it. Actually, it does. 2 times 7. So 14 is 2 times 7. And then you have a pair, which is 7. So the 1 7 comes out. 2 does not have a pair, so it stays inside. That's the radicand. Number 16. I can combine these. I got +1 times -1 would be -1. And then I'm going to leave this as 6 times 30. And if you think about 6, 6 is 3 times 2. So I'll change that. And to put them in order, I'm just going to leave it here for now. And then 30 is 2 times 15. 15 is odd. 2 does not go into 15. Next number is 3. 3 times 5. So I'm going to put these in order. I'm going to put 2, 2, 3, 3, 5. So all I did was write 2, 2, 3, 3, 5. You don't put 15 because you broke it up. Now you can look for pairs. You have a 2 that comes out. You have a 3 that comes out. You have a -1 that stays on the outside. And a 5 that stays on the inside of the radical. 2 times 3 is 6, times -1 is -6. So you get -6 square root of 5. And I ran out of room. So that is how you multiply. So now we're going to talk about division, and as long as they're the same radical, you could divide. So like 10 divided by 2 is 5, and then 5/3, you could reduce 5/3 if you can, but 5 over 3 doesn't reduce, so they leave it as 5/3, and then 10 divided by 2 is 5, so we're done. So if you have two radicals that are division, you could divide them together. So for example, you could take 27 divided by 3, which is 9. So this equals the square root of 9. And that's only if they're the same index, which they are. They're both 2. And the square root of 9, if you need to, that's 3 times 3. So one pair comes out, and you're left with just 3. You do not have to show this work if you could do that in your head right here. Okay. 48 divided by 6 is what? 8. 8 is not reduced. So if I think about 8, 8 is 2 times 4. 4 is 2 times 2. So I get that equals 2 times 2 times 2. 1, 2 comes out. 1, 2 stays inside. I have this one memorized. Anytime I see square root of 8, I put 2 square root of 2. It is always going to be 2 square root of 2 for square root of 8. Okay? And then 37. 8 over 5 does not reduce. 15 divided by 3 is 5. So you're just going to get 8, 5. Stays the same. 15 divided by 3 is 5. So this stays square root of 5. 5 is just 5. 5 is prime. There's no way to break up 5. So we're good. Now in all of these problems, there's a rule in math, and the rule is there should never be a radical in the denominator. So notice, this is really 3, and that's 3 over 1. There's no radical in the denominator. The radical's in the numerator. So there's a rule that you do not want ever the radical in the denominator. And that's called, we're going to teach you how to rationalize, and we're going to be using rationalizing a lot in the next lesson. So I will just show you how to rationalize the very simple ones. When you get to algebra 2, this becomes much more complicated. So if I have 1 over square root of 17, it is not okay to have square root of 17 in the denominator. So here's the trick. It's not a very hard trick. You multiply by 1. But if you multiply by 1, it stays the same. So instead of 1, I'm going to write this as square root of 17 divided by square root of 17. Square root of 17 divided by square root of 17 is 1. If you multiply by 1, it stays the same, so I did not change it. Now, why would I do this? Well, you would get 1 times square root of 17, which is just square root of 17. You could put the 1 in front if you want. You don't have to. And this becomes square root of 17 times 17. Which now we have a pair of 17s. So this simplifies to square root of 17 divided by 17. So long story short, whatever's here, you multiply numerator and denominator by, and the square root of something times the square root of the same thing, the square roots cancel. So then you just get 17. So I usually skip the second step. So I'll show you real fast number 6. So you multiply this by square root of 11 over square root of 11. 11 times square root of 11, the 11 is outside the radical, the 11 is inside the radical. You cannot take 11 times 11. One's inside, one's outside. But you could put 11, square root of 11. And here, square root of 11 times square root of 11 is square root of 121, which is 11. The square roots cancel each other out. So I just get 11. And then from there, I could reduce 11 over 11 and just get square root of 11. If you don't believe me, let's try this in our calculator real fast. (11) divided by square root of 11, and then square root of 11. They're the same thing. Just square root of 11 is a lot simpler. So you might get in a habit and you start multiplying by square root of 2 over square root of 2. But notice here I could reduce this. So instead of multiplying by square root of 2 times square root of 2, which you could do and get the same answer, instead, let's go ahead and reduce 98 divided by 2 because they're both in a radical. 98 divided by 2 is 49. And the square root of 49 is 7. Now that would be the shortcut method, which in this problem we could do. We couldn't do that on this problem because 11 is not in a radical, 11 is. So you cannot divide 11 by 11. But because 98 is in the radical and so is 2, we could divide those. Next, 7 over 11. I could reduce that if it did, but 7 over 11 doesn't reduce, so let's just leave it like that. And I'm going to multiply both by square root of 11. Now here you have 7, here you have 11. They're both prime numbers, so this is not going to reduce any. So I'm just going to go ahead and multiply 7 times 11. They're both inside the radical. 7 times 11 is 77. Here, the square roots cancel. Square root of 11 times square root of 11 is just 11. I cannot take 77 divided by 11 because 77 is in the radical, 11 is not. So this is my simplified